Hello friends, myself Mehul Godia from LJ Institutes of Engineering and Technology. So in last session we discussed about dynamics of machine subjects. So in today's lecture we start one interesting chapter, that is flywheel. So what is flywheel, what is the function of flywheel, and what is the application of flywheel? We have to discuss these things in this lecture. Clear? So what is flywheel? So flywheel is a mechanical device which is used to store the kinetic energy and supply that kinetic energy whenever we require. Clear? Okay. So in today's session we have to discuss these two main topics, that is turning moment diagram for single cylinder 4-stroke engine and turning moment diagram for the multi-cylinder engine. For the understanding turning moment diagram, we have to understand that working of engine and transmission system. Clear? So first of all we have to understand what is flywheel and where flywheel mounted. So flywheel mounted at the end of crankshaft. Clear? And flywheel have some mass. So due to inertia force, flywheel gain some kinetic energy. Clear? So flywheel gain energy at a third stroke, that is power stroke. Clear? Okay. Now flywheel mounted at the end of crankshaft, you can see in this figure, that is after crankshaft, at the end of crankshaft flywheel mounted. Okay. So flywheel gains some energy at a power stroke, and that energy flywheel supply, after flywheel supply this energy to the gearbox, and after gearbox we transmit power to the wheel. Clear? So this is the working of engine. Okay. Now for the understanding turning moment diagram, we have to understand that working of IC engine. So there is a 4-stroke in engine. First stroke is a suction stroke, second stroke is a compression stroke, third stroke is a power stroke, and fourth stroke is a exhaust stroke. Clear? So in suction stroke, piston move top end side to bottom end side. Clear? So in this stroke, air fuel mixture come inside the cylinder, but for the piston move top end side to bottom end side, we have to supply some power. Clear? Second stroke is a compression stroke. In compression stroke, piston move bottom end side to top end side and compress the air fuel mixture. Clear? Okay. In third stroke, piston move top end side to bottom end side. In third stroke, that is a power stroke. In power strokes, we use spark plug for the spark. If we spark is occur, then fuel is explode, and due to fuel is expand, piston move at very high speed from top end side to bottom end side. At that time, crank gains some torque, and this torque rotate the flywheel, and flywheel gains some energy. Clear? So in power stroke, flywheel receive maximum energy. In 4-stroke, piston move bottom end side to top end side and remove out exhaust gases from inside the cylinder. This process also known as a scavenging process. Clear? So this is the simple working of engine. Clear? So in working of engine, you have to understand that flywheel gain energy at the third stroke, that is power stroke. Clear? Okay. Now we have to understand that turning moment diagram for the single cylinder 4-stroke IC engine. Okay. So we get one power stroke after 2 revolution of crank. Clear? In first revolution, suction stroke and compression stroke is running, and in second revolution, power stroke and exhaust stroke is running. Clear? The length of the stroke is 180 degree. In radian, that is pi. Clear? In suction stroke, piston move 0 to pi, that is 180 degree, and in suction stroke we have to supply the energy, because we have to transfer piston from top end side to bottom end side. Clear? Okay. So in this diagram, 2 types of loop, that is first one is a positive loop, second one is a negative loop. Clear? In negative loop, we have to supply the power. In positive loop, flywheel gains some power. One more thing, positive loop indicate work done by the gases, and negative loop indicate work done on the gases. Clear? So in work done on the gases, we have to supply the energy, and work done by the gases means we gain some energy. Clear? So in suction stroke indicate, negative loop indicate we have to supply the energy, but at the end of suction stroke minor positive loop also indicate. So that minor positive loop indicate flywheel gain some power at the end of suction stroke. The reason of that is if any body is in motion and if we apply small force, then that effect of this small force is very large. So in a suction stroke, piston move top hand side to bottom hand side, and air fuel mixture come inside the cylinder, which continuously increase the weight of air fuel mixture, and that push the flywheel to push the piston to the downward direction. So that is the effect of this force is negligible, but we get flywheel get some energy at the end of suction stroke because of that. Clear? Okay. And second stroke is a compression stroke. So compression stroke, a loop of compression stroke is negative loop. So we have to deliver the power in compression stroke because we have to compress the fuel. Clear? Compress the fuel means we have to work done on the gases or fuel. Clear? So we have to supply the energy. Clear? Okay. Now third stroke is power stroke. So in power stroke, we use spark plug for the spark. Once sparks is occur, so air fuel mixture is expand. Clear? Explosive, and because of that the pressure inside the cylinder is very high, and because of that piston move downward direction at very high speed. So because of that crank get some torque, and this torque we have to use to run the flywheel, and flywheel because of inertia force flywheel gain some energy. So in power stroke flywheel gain maximum energy. Clear? Okay. So next stroke is exhaust stroke. So in exhaust stroke again we have to supply the power for the piston move bottom end side to top end side and remove out the exhaust gases from inside the cylinder. This process also known as a scavenging process. But at the end of exhaust stroke minor positive loop also indicate. So this minor positive loop indicate that flywheel gains some power at the end of exhaust stroke. Okay, so in exhaust stroke, piston move bottom end side to top end side and compress the exhaust casing. And at the end of exhaust stroke, suddenly outlet valve open. So pressure inside the cylinder is suddenly reduced. So because of that, flywheel piston gets some jerk in upward direction. So crank gets some torque and flywheel gains some energy. That's why at the exhaust stroke, minor positive loop. So this is the turning moment diagram for this single cylinder 4-stroke IC engine. Clear? Okay. So next topic is turning moment diagram for the multi-cylinder engine. So you see in this figure that is a multi-cylinder engine. So in this figure there is a 3-cylinder. Clear? And end of the crankshaft we mounted flywheel, and at the other side of the crank we also mounted one transmission system, power transmission system. Okay, so crank also transmit power to run the cam and follower device. Cam and follower device used to operate inlet and outlet valve of the cylinder. Clear? So in this the multi-cylinder engine, the number of cylinder is more, so we get more power stroke. So if we get more power stroke, then flywheel gain more energy. If flywheel gain more energy, then fluctuation of speed is reduces. Clear? So this is the multi-cylinder engine. Clear? Working of multi-cylinder engine. Now we have to understand that turning moment diagram for the multi-cylinder engine. The turning moment diagram is versus turning moment versus crank angle. So you see in this figure there is a positive loop and negative loop. Indicate the positive loop indicate flywheel flywheel receive some power, and negative loop indicate flywheel have to deliver some power. Clear? So this positive loop and negative loop indicate. Clear? So in multi-cylinder engine flywheel gain more energy, so fluctuation of speed is too less. That's why a positive loop and negative loop is continuously between upper and lower side to mean resisting torque line. Clear? So this is the multi-cylinder engine turning moment diagram for the multi-cylinder engine. Clear?